Hi, in this video we're going to continue our look at keyword arguments. So let's jump straight into the code. And just as a reminder, let's look at a function that takes in 3 positional parameters. And all we're going to do here is just print A, B, and C. So now we can call this function by using positional arguments. We can call it with 1, 2, 3, and you can see that we had A was 1, B was 2, and C was 3. But of course, as a caller, we have the option of using named or keyword arguments when we call this function. So we could say func1, and we could start with 1, that would be A. But then if we want, we can say C equals 3. And of course, remember that once we start using named arguments, we have to continue using named arguments. So in this case, I would have to specify and say B equals, in this case, we'll make it equal to 2, and we'll get the same thing. You can specify all 3 of them if you want. You can say A equals 1. Actually, let's start with C equals 3, B equals 2, and A equals 1 if we want. Again, the order is not mandatory since Python will map based on the name of the argument and the name of the parameter in the function definition. But the key here is that it is up to the caller to decide whether they want to use a named argument or a keyword argument or not. We can, however, force this by using the star args. If you remember from the last video code that we had on the last section, if we do A, B, star args, D. Well, star args exhausts, right? So again, if you just want a quick reminder, if we do this, we can print A, B, args, okay? And we can call func1 with 1, 2, 3, 4, for example. And you'll notice that A was 1, B was 2, and then args was the remainder, right? It kind of scooped up every other positional argument that was defined here. But we can continue doing this, and we have star args, and then let's define another parameter. And then here we'll just print A, B, args, D. And if we call the function, we can try calling it with 1, 2, 3, 4, we want that to go into args, and then we want D, so let's say we specify 5. But if we do that, we'll get an error. And the error is because, well, star args says scoop up all the positional parameters. And so it did. And guess what it scooped up? 3, 4, and 5. And so it didn't find D. So we have to somehow tell Python, no, 5 is D. And the only way to do that is now to use a keyword argument, a named argument. So we have to do this. So this is how we can force someone who's calling our function to use a named argument. And if we do that, then indeed we get what we expected. 1, 2 for A and B respectively, 3, 4 for the args tuple, and 5 goes into D. Now we can even go ahead and do something where we don't have mandatory optional parameters, because here A and B is mandatory, right? So we can do this. Def func1 will start just with star args and then D. So D is still going to be a mandatory keyword argument. But here, notice that we just say star args. And what this means is, hey, just, if you want to call this function using 1 or 0 or more positional parameters, go for it. And all that's going to happen is that it's going to scoop up all of them, toss them into the args tuple, and then it's going to look for the keyword argument D. So here we can call func1 passing 1, 2, 3, for example, and then D, let's say we'll make D equal to A in this case. And so we get 1, 2, 3 went into the args tuple, and D was equal to A. But of course, that means that we can also call it this way. We don't have to specify any positional parameters, any positional arguments, because, well, we don't need them. So in this case, that works equally well. D is equal to A, and the args tuple is empty, as we expected. Sometimes we want to actually create a function in such a way that no positional parameters are allowed. And we can do that quite simply by using the star by itself without using a star args or star C or whatever you want for the variable name. And we just use a star, and then we specify our keyword argument after that. So this star basically says, hey, this is the end of all positional parameters. After that, everything is going to be keyword. So in this case, we'll just print D out, and let's see how we might call this function. maybe we want to say, hey, let's pass in a couple of, positional parameters. The star is there. Maybe it will just scoop them up and discount them. Maybe that's how it works. And then, of course, we have D, which has to be passed as a keyword. So let's go ahead and set it to 100. But if we do that, you'll notice that we get this error. Func takes 0 positional arguments. It doesn't have any positional arguments. This star here doesn't scoop up the positional arguments and toss them away. It says, no, I don't want any. I don't want to see any positional arguments after this point. But we gave it 2, so it complains. So the only way to rectify this is not to provide any positional arguments. So if we do that, then everything works just fine. Now, of course, sometimes you want to mix that up a little bit. You may want to say, well, I want a function which is going to take 2 positional parameters. It's going to have no more than 2. And then I want a keyword parameter. So here we go. And then let's go ahead and print a, b, d. So when we call the function, we can now call it with 1 and 2 positional parameters. If we try and call with additional positional parameters, let's try that. Let's pass 3 and then let's specify D as maybe 4. But if we do that, you'll notice that Python now says, this function takes 2 positional arguments, but 3 were given. Yeah, I gave it 3. It only expected 2. So that's a problem, and we just rectify this by not passing in more than 2. And so there we go, and we get 1, 2, and 4 in A, B, and D respectively, which is exactly what we were hoping to get. Now, default values, we know that we can use default values for positional parameters. Well, we can use default values for keyword parameters as well. So this is where things kind of start getting really interesting. So let's define again function. Let's say we have A, which is going to be just a positional keyword, argument that will have no default. Then we're going to specify B, but we will give it a default. Let's give it a default of 2. So in this case, what's happening is that if we were to leave it at that and try and call this function, then we could specify just A. So we only would need 1 positional argument to call the function. And if we didn't provide 2, then B would default to 2. Additionally, we can now say, well, we have some additional arguments. Okay. We'll see if that works. And then we have a keyword argument. And let's go ahead and just print A, B, args, D. So let's try and call the function. Let's say we say, okay, we have A, we have B, which will make, well, A will be 1, we'll make B equal to 5, then we'll put in a couple more positional arguments, 3 and 4, and then we'll finally specify D as A. And that works correctly. We have 1, 5, 3, 4. You'll notice here that even though we have a default value, remember we said that once you start creating parameters with default values, you always have to have default values for the other ones that come after that, for the positionals. You don't have to do it when you're using *args. So hopefully you had some raised eyebrows when we wrote this, but rest assured it works correctly. So let's continue doing this a little bit. Let's provide now some default values for the keyword parameters as well, which we can do. So we can say this, let's say A, B equals 20. We can do *args, and we'll take D, we'll default that to 0, and we could put E. Now, it's a little bit different with the default values for the keyword arguments. In the positionals, once we start defining a default value for a positional argument, every other named positional argument after that needs a default value too. Not the case with the keyword arguments, because remember, we're going to be specifying them using keywords, using names, so it doesn't matter. So we don't need it. So we can leave it at that if we want to, or you can specify a default value. And I'll just leave it as nothing. Now, if I don't supply a default value for E, that means that E is now a mandatory keyword argument, right? If I don't specify a value for that, so let's go ahead, and let's print A, B, args, D, E. So that's our function. So now I can call the function specifying maybe 5, 4 for A and B, then maybe 3 and 2, and 1 for the args. I'll let d be equal to 0, so I'm not going to specify d, and I'm not going to specify e either. Now that's going to fail to run because e is required. It's a required keyword only argument, so I have to specify e. So I might make e equals all engines running. And so what we get now is that 5 and 4 went into A and B, 3, 2, 1 went into args, 3, 2, 1. We didn't specify d, right, when we called the function, so it's going to have a default of 0. And then e we specified as all engines running. So there we go, 5, 4, 3, 2, 1, 0, all engines running. Okay, of course we can do other things too. So we can call the function, let's call it with 0, 600, let's say, for B. Then D, so I'm going to skip the args altogether. That's it for the positional arguments. And now I'm just going to go and specify values for D and E. Now note that D's default is 0, but it doesn't mean that D has to be an integer. It can be anything. Remember, we're not statically typed in Python. So D could be, you know, good morning. If I can spell it. Right? So we have good morning, and maybe E will say Python. So when we run this, we get O600, good morning Python. Right? The O, the 0 basically, went into A, the 600 went into B, good morning went into D. We didn't have any additional positional arguments, so args is just an empty tuple, and then Python went into E. We can also do the following. Again, as I said, we don't have to stick to, you know, it's not because we have A and B equals 20 that B has to be an integer. It can be anything. So we could also call it this way. We could say func 11, and then for B we can make it a string. That's fine. So 11 meters per second, and for the star args I'm going to provide 2 more. And again, they don't have to be homogeneous types. So the first argument could be 24, right, of the star args, of the basically the additional positional arguments. And then we'll do miles per hour, right, as the next one. And then D, we can make that into a string, maybe unladen. And E will make that equal to swallow. Okay. And so when we run this, we get A was 11, B was meters per second. The star args, the args parameter became the tuple with 24 and mph, and then D was unladen and E was swallow. All right, so that's kind of putting everything together. So far we've seen how to create positional arguments, how to have optional positional arguments by specifying basically a default value. We've looked at how to scoop up extra positional arguments, so in any number, a variable number of them, using the star args approach. We've seen how to stop taking in extra positional arguments using the star just by itself, and that also allowed us to specify functions where we didn't have any positional arguments. And then we saw how to specify keyword arguments, and keyword arguments that became either mandatory or optional, depending on whether they had a default value or not. So we've almost got everything covered with functions. We're still missing one piece. If you think about positional versus keyword arguments, when we're looking at positional arguments, we have a way to scoop up an arbitrary number of positional arguments. What we haven't seen so far is there a way to scoop up an arbitrary number of keyword arguments? And the answer, of course, is yes. This is Python after all. It's extremely flexible. So the answer is yes, and that's in the next video coming right up. So thanks for watching, and I'll see you in a bit.